Welcome to The Explainer. Today, we're looking at why chemistry constantly tricks us into thinking we totally get it. Ever memorized an equation perfectly but still completely bombed the test? Trust me, you are definitely not alone. It's the Dunning-Kruger Effect. We wildly overestimate our grasp of chemistry by just memorizing algorithms instead of core concepts. Shockingly, over 50% of students hold deep-seated misconceptions about the basics. That literally ruins their entire foundational understanding. So let's break down these common mistakes into two lists: chemical bond errors and buffer solution confusions. Looking at the data, it's wild to see just how incredibly widespread these specific conceptual errors actually are. All right, jumping into list one, the absolute biggest conceptual errors we make when it comes to chemical bonding. First myth, ionic bonds happen between molecules. Actually, no, they form between ions in a huge continuous lattice. We also just treat formulas like mere letters, totally ignoring the actual 3D structure and how charges balance. Another huge mistake is splitting polyatomic ions apart. They act as one single cohesive unit, kind of like a tiny gang. The fix? Always use the periodic table to predict those ion charges, then explicitly balance them out to neutralize. Moving right along to list two, the deep-seated, super common confusions surrounding buffer solutions. So a buffer resists drastic pH changes, right? But it definitely doesn't just magically make acids disappear. Way too many students think buffers completely neutralize acids and bases. But honestly, that is just a huge myth. It's actually a dynamic equilibrium. Adding strong acids still causes tiny microscopic shifts in that overall pH balance. So why exactly do our brains keep falling into these same traps? What's the real root cause here? Well, it comes down to prior misconceptions, the super abstract nature of chemistry, and honestly, really ambiguous textbook language. We rely way too much on oversimplified models. We fail to connect symbolic equations with actual real-world particle behavior. The vital takeaway here? You literally must connect the macroscopic, submicroscopic, and symbolic levels to actually master the science. Which leaves us with this. Are you just memorizing the algorithms? Or do you actually understand the particles?